Alright guys, so this is the last of the 3 videos, and so this last problem, I want to read it to y'all because this is not something that we specifically covered in class, but I'm going to go ahead and go over it through this video because it is something that you know how to do. It's just maybe you don't know the wording on it. So this problem reads, it's a cold winter morning and you've made a cup of hot chocolate. The rate at which this hot chocolate is cooling is modeled by the following equation, where T is the temperature of the hot chocolate, the big T is the temperature of the hot chocolate, and the little t is the time in minutes that pass by. So I'm going to rearrange this equation like you see here. Okay, so since this is an exponential, remember base e with a number with an exponent, and the x is in here, this is an exponential equation. Usually what I've been dealing with is looks something like this. So 75e to the negative 1.5t plus 65, where 75 is my a value and d is the d value. Okay, so if I want to describe the transformation of this graph, guys, remember I'm going to use my stuff over here. Remember that for exponentials all I was moving was a and d, but I want you to notice something. I have a negative in the exponent, so negative means reflect in the y direction. So first thing is I did reflect across the y. Okay, and now I'm going to go ahead and deal with the a and the d. So a means that I am moved, or excuse me, I vertically stretched in the y direction, so I mean vertical direction, by 75. And a value for d means that I moved, since it's plus, I moved vertically, or in the y direction, move vertically up by 65. Okay, so what that means in terms of my asymptote, guys, remember it in a regular exponential equation it's at y equals 0, but remember with the d value, like we already covered in the other graphs, I moved up by 65. So I moved up by 65, which means the asymptote is now at y is equal to 65. It's not a very good 5. Excuse me. So last question here is, when will the temperature of the hot chocolate reach 100 degrees? So right here, guys, this is where I have to decide. Remember, I have big T, which is the temperature, and little t, which is a time. So here they gave me 100 degrees as a temperature. So what I'm going to do is I'm just going to go ahead and plug this into NSolve, where my big T is 100, and my equation is this one right here, 75 e to the negative 0.15 t, or x is the way I'm going to plug it into my equation, plus 65 comma x. And when I plug that in, guys, again, put an x, not a t, I'll find that t is equal to 5.08 minutes. Okay, so next problem here, try on your own. Okay, again, I'm going to go ahead and go back to the very beginning so that you guys can check your answers. So this next part's going to go by kind of fast. So go ahead and check your answers. Again, I'm going to go through these so y'all can see. This is the answers for 1 through 4. Oops, I did not box this one. Again, this one's the answer right here. And I didn't box a lot of my answers. That's not good. Okay, this one right here. This is the end result. This is my box. Sorry about that. So move on to the second page. So this one I have just an A, B, C, and D, so check your answers. Okay, right here, okay. So notice I didn't have an A or a D here, so I really don't have any transformation to go by. Okay, so this is the answers right here for... Ooh, I didn't put my domains and ranges here. Okay, so this is the answer for part A. I didn't mark this correctly, okay. And for part B, the domain here was, like we said in the other problem, 1 through infinity, and range was negative infinity to infinity. And over here, the domain is also 1 to infinity and negative infinity to infinity in the range. Okay, this is my transformation. Okay, now I have a bonus problem here, just so I can go through it with y'all. Extra example. So imagine I had a b value of 1/4 here. Okay, remember when I take this out, I have to find some number that when I multiply by 1/4 will give me back this -1. So what I told you all to do is multiply by what you have on the bottom. Okay, so remember this is to the x minus 4, so plus 3. So if I had a b value, I would have moved to the right by 4 from this c value. Okay, I would have stretched horizontally by 4. So remember, you take the flip of this, and had this been, since it's a fraction, that's a stretch. And then I went 3 up. Okay, so just keep that in mind, guys. I know I didn't give you any examples that had b values, but be careful with them. Okay. Okay, so moving on. These are my answers here. Again, I didn't box them. Okay, and for the last one here, again, I said I would go through this with you all. So Daniel's going to invest $4,859 in a retirement account with a fixed annual interest of 6%. If he leaves his money in the account for 16 years, how much more will he save if the interest compounded continuously as opposed to compounded monthly? So here, guys, I'm going to do this twice because I want to compare numbers. So once with a compound continuously, which means I use the PERT equation, and one where I compound monthly, where I'm going to use this longer equation. Okay, so what I did is I solved. This is if I compound monthly and I get a value of 12,659.91. And if I use PERT, I get 12,690.23. Now, I want to know how much more will I make continuously than compounding monthly. So if I subtract these two numbers that I found, then I'll see that I make $30.32 to be exact, if I compound continuously. So that's what this question is asking. And the last problems here, guys, again, we went through the first one here piece by piece, and then the answer for the last one would be this one right here. Okay, so study hard, guys. Like I said, this review will be due on Tuesday, right before the exam. Again, guys, please study. I know it's a 3-day weekend. I know we want to relax, but we are testing, so you do need to study. Please do so. Okay, have a good weekend. And if you have any questions, guys, you can reach out to me by email. Okay, so